Hello everyone. Today is the 31st day of Leetcode 75 challenge. Let's begin with the 31st question. Question 206, reverse linked list. The level of the problem is easy. I will request you to read the question beforehand as I will deep dive into the PPT and explain it in simpler way. So you are given a head of a single linked list, fine, and your task is to reverse the linked list so that the last node becomes the new head and each node points to the previous one, and we return the new head of the reverse linked list. So basically, if this is the linked list which is given to you, it will be 1, 2, 3, then 4. Then the reverse linked list will be this 3, then 4. Okay, I will remove this and this will be 4. Fine. So this is what we have to do. We have to reverse the linked list. That's all. And the constraint of the problems are the number of the nodes in the list is from 0 to 5000 and the node value could be from negative 5000 to positive 5000. Okay. The question is not that of a complex one. We just have to reverse the linked list and return it. That's all. I hope you understood this problem explanation. Now let's move to the next slide. Let's understand the input-output explanation. So if you can see here, we are given a linked list 1, 2, 3, 4, 5, right? And we have returned 5, 4, 3, 2, 1, right? If you can observe, the arrow or the pointer has been changed to this direction. That's all, right? And similarly, in this case, if you could see, 1 was pointing towards 2, and now 2 is basically pointing towards 1, right? That's the thing. There is nothing much complex about it. Okay, now let's move to the next slide. Now, to understand what the problem is asking, we should build up an intuition to the problem. Fine. Let's start by understanding what is our goal. So we are given head of a single linked list. Let me draw out a single linked list here first. Let this be a single linked list. Okay. So our task is to reverse the entire linked list. So the first node becomes the last node. Of course, when we will reverse this linked list, this node will become the first node, right? And this will become the last node because if you could see, assuming this points to the null. So when we reverse it, so this will point to null and this will point to here and this will point here, right? That's the thing. So we cannot use extra arrays or build new list. We must rearrange the existing node links. So this is the thing which is asked to do, right? But what is the brute force which comes to our mind? First brute force comes to our mind is that we iterate the complete linked list, we iterate it, right? And we store it in a list. We store all the values of the linked list in the list like 1, 2, 3, 4, right? Then we could do one thing. We could iterate from back to front and create a new linked list from it, right? Or you could just reverse this and create a new linked list. Yeah, this is the two things which you could do. But the issue here is that you are using an extra space, right? And it is also not that efficient. Yeah, the solution is correct, but it is not that much efficient as we want, right? Now, another which comes to your mind is using stack. The concept of stack. Bit efficient way could be use the concept of stack. So if you remember, if we had values in the stack while iterating through the linked list, it would be 1, then 2, then 3, then 4, right? And we when we pop the elements, it will be 4. Then we create a next node, which will pop 3, and we will pop 2, and then we will pop 1, right? I have written it this way. So this is the linked list which is created from here, right? But here again, we are using O and space, right? We don't want to use that. We are not allowed to use that, right? So what we could do, since we are asked to do it in using in place, using O of one extra space and O of n time complexity, right? So these two brute force methods are correct. They are not wrong logically, but yeah, they are against the constraints or the information given in the question. So now let's try to visualize the process. Imagine you have a chain of A, B, C, D, E, A, B, C, D, right? Let me create it here also. A, B, C, then D, then this points to null. Fine, this is what is given to us. Now reversing it means transforming this given node into a this way. Yeah, this points to null. Correct. So this becomes the head, of course, because this is the start pointer, and this becomes the we could say the last. Fine. Now to achieve this, To achieve this, we need to carefully flip the next pointer of each node so that it points to the node that came before it rather than the after. So what we are trying to say here is that if A is pointing to B and B is pointing to C and C is pointing to D, and if you are trying to, we have to basically flip the pointers, right? So if you try to flip this pointer to this direction, so there are a couple of things you have to keep in mind. First is that you should be knowing that you should be storing the previous element with us, right? If you could see here, as we reverse the direction, we must also keep a track of the node that was processed, right? So each node knows what to point back to. So basically, if you just come here or you just come in the node and just reverse it without knowing what was the previous node was, how you could able to do it, right? But at the same time, you also need to store the next node to the original sequence before changing any pointers. We don't lose access to the rest of the list. So to summarize this complete thing, just have a practical thought in this here that if you think of reversing this arrow, just take it as an arrow. You have to know what was before, correct, and what was after. Because if you don't know the after node, you won't be able to iterate the complete linked list, right? And if you don't know the before node or the previous node, you won't be able to reverse the direction of the pointer. Fine. That's why we need some kind of in-hand pointers or some help so that we could store the previous and after values and we could reverse the direction of the arrow. Fine. And we also don't miss the complete iteration of the linked list. So now in a nutshell, basically, if you want to reverse this node, you need to know the previous node, fine, and the next node. Fine. These are the two things we figured out that we have to know the previous node and next node, and we have to store it somewhere, and we have to also keep the uh, you know the link between the nodes in the relative manner as it was before, right? We just have to reverse the arrow direction. That's all. So how we can simulate this, right? We came to know that we need two pointers in this case, fine, and how we will implement it right now. So how we can simulate this? We could start with two pointers, right? One could track the current node. This is one will track the current node. Of course, we have to check whether in which node we are, right? And we could also keep a previous node with us, fine. And also we will be needing a next node, fine, or pointer I would say rather. Let me write it as pointer rather than nodes. I will write it as ptr, fine. Now in this case, the current pointer will point to current node, fine, and previous pointer will point to previous node, of course, fine, and the next pointer will point to next node, cool. So why we are doing this? First of all, let's understand that initially the previous pointer will point to none and the current pointer is set to the head of the linked list, fine. And as we traverse the list, we first store the next node in a temporary variable so we don't lose the access to the rest of the list. Okay, so we are clear about this thing. Okay, what will current pointer, previous pointer, next pointer will do? I will just remove it from here now. Suppose uh, this is the linked list given to you. Fine, let's take only three values. So what could we do? We could point the current pointer in the head of to the head of the linked list or the first node. We point it like this: current CURR, fine. And let's take previous node which points to null. And why null? We will come to know. Fine. Okay. Now when you are standing in current pointer, you know that this one point is pointing towards the two, right? But if we have to reverse it, this should point here, and let me draw the reverse directions also, right? So this should point to the null, right? Correct. So to do that, we need the previous pointer, right? Here, if you could see, we have the previous pointer pointing towards null, correct, right? And before pointing this node to the previous, you should have the access to the next node. That is what the next pointer will help in doing us. Fine. So if you have the pointer to the next node, or you know what is the next node after the current node, you could easily remove this, right, and point this to the previous pointer. Fine. This is the previous pointer which is pointing towards null right now. So this will be removed and you have null here. Correct? Great. Now after this, for this two, one becomes the previous, right? Therefore, we move the previous pointer in the position of current pointer. Fine. And since now we have the connectivity and we know what is the next pointer, which is next node after one, which is two, which is pointed with the help of next pointer. So I will bring the current node to the next one. Fine. So with the help of the next pointer, current node comes to the next pointer pointing value. Fine. And after that, again, what we will do, we will just try to move the next to the next node. Fine. And we will remove all of this and we will try to point the current next value towards the previous value. Fine. Okay, great. Now you have the value. So you will remove the previous because for this node, this is the previous. So you move previous to the current and you remove this current and you bring it to the next node with the help of the next pointer. Fine. This is pointing towards null. I forgot to write that. Now again, if you could see, this is done, right? Then next pointer has the comes to the null part. Fine. So this is done basically. Fine. It's pointing towards the null now. And now current pointer could point to previous. Great. So this will get removed and previous pointer will come to the current pointer's place. Now current pointers moves ahead and it is done. We are done with it, right? Now what is the head of the reverse linked list? If you could see, it is 3, right? So we will return previous. So this is our answer, or this is our intuition and how we could able to do this, right? If you could see here, we first store the next node in a temporary variable so we don't lose the access to the rest of the list. Then we reverse the direction of the link by pointing the current node to the one that came before it, which is basically the previous node. And after that, we shift both pointers one step forward. The previous becomes the current, as we did. The current moves to the next node we stored earlier. Fine. We repeat this until and unless the iteration of the complete linked list is done. So this is the way we will able to simulate this complete process using the help of 3 pointers basically, right? 2 pointers were declared previously, then using the next pointer as a temporary one. So I'm telling it as 3 pointer use. Fine. So what we figured out from the intuition, right? We figured out that a linked list can be reversed using a single pass by redirecting each node pointers to its previous one, correct? And tracking the previous visitors using previous, current, and next pointers. We basically need 3 pointers. Fine. This is what we understood from our intuition. So node allows us to, so basically previous node allows us to build a reverse list step by step. So using previous and next, we are keeping the connectivity, right? Keeping connectivity. Because if we don't have previous and next pointer, it will be a basically a difficult task for us to keep the connectivity, right? On the single pass. So temporarily storing the value in the next node or next pointer ensures we don't lose access to the rest of the list, right? Previous help us to build a reverse linked list by having the access to previous nodes and the previous nodes, and the current or the next help us to keep the connectivity or access to the rest of the linked list. Fine. So I hope you understood the intuition. Now let's move to the next slide. Now since we got the intuition of the problem, let's look into the approach how we're going to solve it. Fine. So first let's understand the base case. What will be the base case, right? If example you don't have a head, suppose head is null. So you cannot reverse anything, right? So you just return the head itself. That's all. We return null basically, right? So if there is nothing, we just reverse it. Nothing to reverse basically, right? So this prevents errors or unnecessary operations from the links and it is if the list is empty, right? So this is the prevention which is basically taken by us. And even if the head next is null, which means you only have one node, so there also you return the head directly in the base case because what you will do by reversing this, right? This is only the one node you have. So yeah, that's the thing. Now, after that, we will initialize two pointers. One is current pointer and one is previous pointer. Current pointer will always point to the head of the linked list, and the previous pointer will start with the none. And I hope you understood why we use none, because when this is done, right, and previous is here, suppose, right, and current is here. So this the last pointer always points to null, correct? So this if this becomes the last, this should point to null. And initially, if you remember, the value of the previous pointer was null, so it will point to null directly, correct? And this will get removed later on. So we will use this pointer to traverse the list and reverse links one by one without using any extra space. Fine. Now traverse and reversing the linked list. Fine. While cur is not null, basically while the linked list is not getting completely iterated, what we do, we store the current next in current.next. We store this value in next pointer, fine, which we create. After that, we do current next will be point to previous. So basically, current.next will have the previous value, then previous will have the current value, right? And current will have the next value. Fine. This is the way which we will be doing. So basically, this is the node. I'm just creating this. Okay, fine. So current is here, and current next has the current dot next, for example, right? So suppose next is here, and current next is pointing to previous. So previous is here having the null value. Fine. So what happens? This gets removed, and its next points to previous. Great. And this gets removed. Previous comes here, and this goes, and current goes here, right? And similarly, this was pointing towards null, correct? So again, the same thing will happen. So I hope you understood this. So this will systematically reverse each node direction without breaking the list, while ensuring we don't lose access to any node. Now we return the new head. The new head will be previous, because after iterating the complete linked list, at the end we will have only previous pointing towards the last node. Fine. So that is why we return previous at the end. Okay. So I hope you understood the approach. Now let's move to the next slide. The code is the exact copy of the approach discussed. Let's understand it line by line. Fine. So first we check if the head is none or not. If head is none, we just return head. Fine. That's all. Nothing complicated. So we point, if it is not head, not none, we point head to the current, and we point previous to the none. And now while current is not null, we have the next pointing towards the current next pointing to the previous, previous to the current, and current to the next. Yeah, this is a very easy thing to understand right now, because I have told you multiple times what is this thing doing, and we just return the previous value. So the time complexity comes out to be O of n, because it is a one pass solution of length n. That's all. And we are not using any extra data structures to store the values, so its space complexity comes out to be O of 1. Okay, so I hope you understood this code explanation. Now let's move to the next slide. Now, since we have the understanding of the code, let's look at the dry run of the example. Fine. So let me draw this 1, 2, 3, then 4, then 5. Fine. Uh, Initially, current is pointing towards head, and previous is pointing towards none. Fine. And I will write here next next. Okay. So C means current. Fine. And P means previous. Great. So first thing, next is basically current dot next. So when we come, current is standing here. So the next value is current dot next, right? So next, n means next, fine, n comes here. Great. Let me write the complete steps here for your understanding. It will be much clearer for you to understand then. Okay, so this is the steps I've written here. Okay, n means next, C means current, P means previous, right? Easy to understand? Great. So let's begin. So that currently, current is pointing to the head node, which is we are pointing right now. Previous is pointing to the null, which is here. And next happens what? When I come into the loop, next has current dot next. So n comes here. Now current next points to P. Fine. So this is the current next, right? So this will point to P. After that, P comes to C. So P gets removed from here. P comes here, and current goes to N. So current comes here. Fine. Now again we come here. N has the current next. Current next is 3. So N comes here. This gets removed. Then C dot next points to P. So this will get removed. This will be pointed here. Now P comes to C. We'll just cut it. Okay. P will come here. Then C goes to N. So this cuts from here and comes here. Great. Now again we come here. C dot next, which is this, right? And so N comes here. And C dot next points to P. So this points to P and this gets removed. Great. After that, P comes to C and C goes to N. Great. Let's remove this. After that, again, N is C is next. Okay, I read a wrong thing here. It will be C, not N. So C N becomes C dot next. So it comes here again. N comes here. Then C dot next points to P. So this is C, and its next is here. So it will point to P. Fine. And this arrow will get removed. Now P comes to C, and C goes to N. Fine. Now this please this is pointing towards null. Please keep that in mind. Fine. And now we could see C goes to C is next. So C is next, so it is out of the loop now. Fine. So it will get removed. We'll remove this. Now C is next is this, right? So it's pointing towards P now. So this completely gets removed. Fine. Then comes to C and C goes to N, which is null basically out or after the loop, you could say. So it is out. So we will remove everything. So this is done. Now, if you could see that our linked list is reversed and we will return P at the end. If we return P, we get this as the output. 5 pointing 4, 4 pointing to 3, 3 pointing to 2, 2 pointing to 1, and 1 pointing to null basically. Fine. So this is what's happening. So this is our complete diagram for the problem. If you have any doubts or confusion about the solution we arrived at and how we arrived at it, I would suggest going back and understanding the intuition and the approach and along with the code. After that, do a dry run by yourself on 2-3 examples, and I'm pretty sure you will understand both the solution and the thought process behind it. Now let's move to the next slide. Now, since you're familiar with the problem and the solution, let's move to the lead code and code the solution. So first, we will check if head is none or not. If it is none, we will return head itself. Then we'll create a current pointer pointing to head, previous pointer pointing to none, while current exists. So next, I will create any next pointer, current dot next, then current dot next points to previous. Of course, previous comes to current's position, and after that, current goes to the next positions of node. Right. So we again we return uh, previous. Now let's try submitting for the basic test cases. Okay, now let's finally submit the solution. So we successfully submitted our solution. Now the code of the problem is available in my GitHub repository. You can find the link in the description. Thank you everyone.